Alright, so let's start diving into the wonderful world of VOPs and also maybe touch on some VACs. Because I've noticed that some people find VOPs easier to understand and some people may find VACs easier to understand. It will kind of depend on your background. If you have a background in coding, you will probably be more familiar with VACs. And everybody else will probably find VOPs easier to understand. So the majority of stuff I'm going to do will be based on VOPs, but I will also give some examples on how the same stuff can be done in VACs. And then we'll slowly build up our arsenal of tools that we can use and stuff that we can do. So VOPs stand for vertex operators and VACs stand for vertex expressions, basically. So let me just give you a couple of examples of what it is and what we can do with it. So up until now, so let's make a geometry and let's put down a grid. So up until now, we've been using pre-baked assets to do certain stuff. So we used polyextrude, we used group, we used edit subs, we used a whole bunch of nodes that have predetermined things they can do. So let's put down another of these predetermined things we can do. For example, a mountain. And you can see, so I made a 20 by 20 grid, and now I append a mountain. And you see with this mountain sub, we have like some controls to add like some noise. And it's basically sort of to create sort of a terrain type look, so with noises. So under the hood, what this is doing, it is just adding noises to our geometry. So we can even dive into this thing. So if you double click on this, you find another node. So a lot of the Houdini nodes are actually built up of other nodes. So these are just digital assets that contain other stuff. You can even make them editable if you right click and allow editing of content. We're not going to do that. But if we dive in, we see an attribute VOP. So that's the thing we are going to learn how to use. If you dive in here, you see a whole big network of stuff that's going on. So a whole bunch of parameters. You see a noise there, and you see a whole bunch of stuff going on. So what you see in here is VOPs. So this is what is driving this terrain thing under the hood. So we can also make something like this ourselves. And don't worry, we won't make something with this many nodes initially. We will, be doing that later. But initially, we'll just start off simple. And I'm just going to explain basically what VOPs are and how it sort of works. So essentially, what VOPs and also VACs do is they do certain math operations on every point at the same time. So if you apply something to it, it will apply that thing on every point, which means it can be super multi-threaded. So anything you do in VACs or in VOPs will be multi-threaded because it runs simultaneously on every point at the same time. And then we can determine on like specific things that we want to do by, for example, providing a point number or providing something else. We'll get more into that later. But let's just make a very simple thing inside VOPs. So type attribute VOP. So if you just type VOP by default, you will see a whole bunch of VOPs will appear: point VOP, primitive VOP, vertex VOP, and you have a volume VOP as well. And these are essentially the same thing, except for the volume VOP. But the only thing is that it's different on where they run on by default. So if I make a primitive VOP, for example, it will be set to run on primitives by default. And for now, we're going to run on points. So remember, this is what we had in here: points, vertices, primitives. So anything you do in here will run over the attributes you determine on here. So points will run over points, primitives will run over primitives, vertices will run over vertices. Never really use numbers myself, actually. And detail will run only once. So that might be like if you're generating, for example, geometry inside of this, you might only want to run it once. So we could maybe get into some examples of that later, but maybe that's a little bit too, we'll see. Anyway, so let's dive into this VOP. So then we get into the world of VOPs. And you see there's geometry, geometry VOP global parameters. So this has a whole bunch of parameters, and there's geometry VOP output. So just a couple of basic outputs that you frequently use. So P is for position, V is for velocity, force, CD, color, and N is normal. And then you have a whole bunch of parameters in here. And on my website, timvanhelsdingen.com, you can download a PDF that has all of this information, what it exactly is as well. So just sort of an easy glossary PDF, I guess. But these are just some stuff that we can quickly load in. But we can load in anything we want. Remember, Houdini just works on data. So you can load in anything you want. But for now, let's try to make something similar to the mountain. All right, so let's first so we have our position input here, P. So that's the position for every single one of our points. So every single one of these points has a position attribute, and this is the output position. So if we just plug P into P, it will just take input position and then output it to the position. So nothing changes because it will just be a pass-through right now. We're passing position into position. But in between here, we can do some modifications. For example, let's type an add. So we can do certain math operations. So if you tap here, you see a whole new network appear, by the way, with a whole bunch of new stuff. If you go to math, you can see you have a whole bunch of math operations. For example, add. So let's put an add in between here. And now you can see we have a second input. So what we can do is we can middle mouse on this and then promote parameter. And then we can select it and then say, and then it's similar to the user interface thing that we did before. So we get some options here. So also what this did is it just added so if I go up a level, by promoting it, this added a parameter like we did before as well. So it just added it down here. So we get some controls, and I have it on here, and I can on here say what type of input should this be. So I probably want this to be three floats or a vector. So now it has 3 parameters. I can, by the way, also double click on this, and then it will sort of pop out. And then I have it as a separate node, and then I could add something in between here. Or I could actually also just drop down a parameter myself and then do that myself without. So I could have also just done it like that and then plug this in. Anyway, so we have this thing, and this is set to a vector. So what I can do now is that with this is currently set to 0, 0, 0. But if I increase the y, you can see that I'm suddenly that the grid is moving up. I can do this in the upper level as well because I promoted the parameter. Again, by promoting it, it will add it to the user interface with like we did in the previous video as well. So, and again, like we could rename this like add pulse or something like add to position. You don't really have to do this, but just to show that it's sort of like it will just change the name. So what this is doing is just adding a simple math operation to the position. So this will add whatever I put here to the position attribute of every point. So it will add this to the position of every point. So what that will do is it will move the entire thing to the side. So we can add other stuff in here as well. So instead of just doing something like this, what we could also, like if we were to take, for example, take our point number and put it in there, we get something really weird because now it's going to add the value every point to our position. So that's obviously not something we want. What we could do, for example, is if we type random is also when we did like our attribute randomize, right? That's essentially what this is also doing. It's sort of a similar node. And this will take an input, for example, point number. And then I can say, what do I want to output? For example, I want to output a 3D vector. And if I then put it in, you see, it will add so it will create a random attribute from 0 to 1 for every point, and then add that to the position of the point. So that's why it's gonna look all messy. But you can see this does it well, simultaneously on every point, and we're randomizing the value that we get based on the point number. So you can see this is how we can sort of manipulate stuff inside of VOPs. But of course, this looks a little bit random, so maybe we want to have some more control. Let's put down a noise. Let's put down a turbulent noise. So turbulent noise, you can see it has a whole bunch of inputs. So we need to tell the turbulent noise, like, where should it apply the noise? So it should apply it on our position of our point. So we need to plug our position in there, because else the noise won't know where to be applied. Then we can say what type of noise, like 1D noise or 3D noise. Let's put it to 1D noise for now, so that will mean that it's just going to be a black and white value. And let's plug this into our color. So if I do this, you already see, and by the way, maybe I want to up the resolution of my grid a little bit so we can see some more of the noise. You can see now it added the noise to the color. So you can see it appear in the spreadsheet here as well. And because it's a 1D noise, it will just add it to every part of the color at the same way, because it will just fill up the other channels as well. So you can see we get sort of a noise. And of course we can change all of these things. We can change the frequency. So all that type of stuff. It could also be 3D noise, and then we get colored noise. So that will mean that every so now if you go into your geometry spreadsheet, you see that it gets different values for every color. So it will like for every point. So this will be a 3D noise. And so by putting it into color, it's just easy to visualize what's happening. So that means that this noise is a vector. So what we can also do is, for example, is right now we're putting it into color to visualize it, but we can also take these values that we generated and add them to the position. So let's do that. Now you can see we created sort of a cool sort of terrainy thing. So let's do what we did before. We want to maybe promote some parameters. So let's promote type, let's promote frequency, promote offset, promote amplitude, and promote roughness. So then we go up, and now we have some control. By the way, let's maybe remove the color. So if I hold Y, I can slice sort of the thing. All right, so let's maybe tweak our frequency a little bit. So a little bit lower, and then increase our amplitude. And you can see it's only moving in one direction. So it will depend on your noise type, like the way it will behave. So Turbulent noise will be like that. So if I put simplex noise, it's gonna sort of move in every direction. So now we created sort of a cloth type look effect, I guess. So of course, it's not exactly similar like the terrain, but you can make this look similar to your terrain, depending on like how you change your parameters. So what you often do is that you can also stack multiple noises. For example, I could, for example, make another noise and then add more stuff to the already existing noise. So that will just manipulate the values that come out of here and then just add those in as well. So you can sort of stack whatever your whatever your noise is and just change it a little bit. But you can see how this sort of works. So we can just do stuff in here, and we could add, like, promote this parameter, make this a vector, and then like add to our position this way. We could, let me remove the second noise, by the way, so like that. You could also like make one noise, maybe, for example, with like very big deformation, and you could copy and paste this VOP. No, not the divide, copy and paste this VOP. And make this one higher frequency. It's maybe a little bit too high, but so now you can see we can sort of stack these things together. So now we do big deformations on here, and then we do smaller deformations on here. So of course this will also work on a 3D object. So we have our pig here, maybe not at the shader. Let's just add this to our pig. It's a little bit extreme. Let's only do the second noise maybe. As you can see, now we're deforming our noise, our pig. So we just added some noise to our pig. And as long, like, the point I'm just trying to make is to show how this works on the root. So remember, this just works on every single point. So this is completely multi-threaded. So other cool stuff that we can do, for example, is there are certain parameters in Houdini that you can access to use things. For example, you have a couple of parameters, like, so I can make a note here. For example, there's, so some of these channels, like we timed an expression before, and there's stuff you can use in there. For example, $F will mean frame, $T will mean time. There's other stuff that we're going to talk more about later. $job will be the job direction. I'm not going to get into that for now, but there's a whole bunch of these. Again, you can check the PDF that I provide on my website, timvanhelsing.com, to see more of these examples. But let's say we will type $F in the offset. So if I move the offset, for example, you can see I'm moving the offset of the noise. So that's similar what we were doing when we did it on the grid. And let's not add it to the position, and just add, like, make it 1D noise, put it into the color, so it's going to be a little bit easier to see what offset will do. So if I animate offset, you can see it's just offsetting the positions of the noise. So if we're doing that in here, that's also what's happening. So we can drag this ourselves and keyframe this ourselves, or we could, for example, type $F. So now it will increment by 1 every frame. So this will, of course, be a little bit too fast. So now you might think we want to divide this by 5. So that's not really going to work that well. It does work. So you used to be able, you used to need to specify FF, means floating frame, but right now it actually works by default. So if I just have this set to $FF and then divided by 10, for example, you can see now I have an animated noise moving through my pig. So another of these variables will be $T. So $T will increment by 1 every second. So I am at 24 frames per second. So like at frame 25, it will be at 1, because then it's restarting, of course. So now we see we created this sort of really weird wavy thing. We could also put it into the last coordinate. So now it's happening everywhere. And maybe we want to subdivide our pig. We have some more detail. So now we created this sort of cool looking thing, just with some simple noises inside of our VOP network. All right, so now let's copy and paste our noise. And let's delete the channel in the offset. Put 0, 0, 0. And maybe turn down the frequency a little bit. All right, and let's push up the amplitude. So what you can see is that stuff will be pushed based on the noise in a 360 direction. So this stuff over here has a vector that will be pushed over there. So maybe if I want to visualize this a little bit better, so let's also put this turbulent noise into our color. So now we get it as a color. And right now it's a little bit difficult to sort of view what's going on. So maybe let's make a different visualizer. So if we type in our viewport here, press D on the keyboard, we get display options. Let's go to visualize. And then on here, we can make scene visualizers. So let's make a marker, so the plus and marker. And let's put a vector trail and type CD. So capital C and small letter D. All right, so now we are visualizing the color. So the color is a vector. So we're instead of visualizing it just as a color, we're also visualizing it as the direction that it's sort of pointing, because that's what we're using it for, right? We are using color as direction. And remember, these attributes are just X, Y, and Z positions. So that means that they have a direction. So they have a point in space, they have a direction. So if you look at this, and like now when I'm increasing this, you kind of see that this stuff here is pointing inward. So if I move inside of my geo, you can probably see it. So these are moving inwards of the geometry. So when I'm increasing my amplitude, it will be pushed inwards. Let me delete or turn off my my marker again. So maybe that's not exactly what we want. Maybe we want to sort of add it based on the direction that our surface has. And if you remember, is that our points have a direction, right? That's our normal. So you can see here vertex normals. We can also make it. Let's keep it vertex normals for now. So they have a direction. So let's make a new VOP. So type just attribute VOP. Gonna run over points. Let's go in there. Let's turn off our display of our normals. And let's try something. So let's add our position again in our position. And then we want to add something to our position. But let's, instead of adding our noise directly, let's add our normal. So let's plug it in, and you can see our pig completely inflates. So we made an inflated pig. Hooray! Right, this is maybe a little bit extreme. So maybe what we want to do is, okay, we don't want to add the entire normal, because this will just add the normal, which will be 0 to 1, to the position. So that's why it's inflating this much. We could say is we could put a multiply in between and then promote the parameter, and you see it now it deflates. And this can just be a float. So if we're just putting it as a float and we multiply, it will just use the same value here as a multiplication for all of the components of the vector. So we have our input number, and now if we drag this slider, we can see we can inflate our pig based on this slider. So it's just multiplying the value of our normal that gets added to our position based on this slider. So essentially we now made a peak stop, because if you type peak, it's another stop that we have. It's doing the same, exactly the same thing. I'm not sure if we can dive into there. No, this is a hard-coded one. Some are hard-coded, so just written in C, and you cannot dive into them. So some will be built from Houdini nodes like VOPs, and some will be hard-coded. Essentially, we made a peak stop now. All right, so, but instead of having it control ourselves, like this, we could also say that let's add a noise, like a turbulent noise like we had before. Let's maximize this. So Again, remember, you need to tell it where should it put it, so in the position. Then we have this turbulent noise. Let's keep it as a 1D noise, so one-dimensional noise, because all we're gonna do is because this needs just to be a float, because it needs to just tell how much should it displace the geometry along the normal. So we just use this as a multiplier and then promote our parameters. And move up a level. All right. Now you can see we get a completely different thing. So now it will displace this geometry along the normal based on our noise. So we get a very sickly looking pig. So we created here something. There's actually also a node that does this by default, so just in one node, and it's called displace along normal. So this is just sort of doing what we have already. So it takes position, this takes a normal, and then it takes an amount, and then put it into a position. This does the same. So you can see output for this will be exactly the same. So, but this thing just does what this does, but I was just like showing you both ways how to do this sort of just so you understand what's going on. So this node also has a scale, so that would be the amount that it gets sort of inflated. But we could also do that ourselves because we already have a multiply here, so we can add another multiplication by promoting this other parameter. Let's plug that in. And then we have, and I kind of noticed that I think maybe our own little thing even seems a little bit faster. I'm not sure if it matters, but you kind of see what we're doing. We're just doing simple math operations. Let's delete our displace along normal maybe. I'll just keep it in here for the file. So we're just doing simple math operations. So we're just taking position and then adding our normal, but the normal is multiplied by our noise. And again, we can just put put like a $T or something in here and just play. You can see now we have a noise moving upwards through our pig. So instead of maybe just only using this to drive, for example, positions of like a pig like this, you can also output these values you do in VOPs to do other stuff. So let's make another VOP. Attribute VOP. Put it in here. Now maybe let's add it on a grid. It's probably better. So let's put a grid. Make the grid whatever, like 50 by 50 or something. Let's go in there. Let's put down a turbulent noise. So plug the position into the position. And let's for now put this in color so we can sort of visualize it. Let's promote some parameters. All right, so we have these parameters. We can look in our spreadsheet. And you can see we have some values going on here. Now, you remember we did an attribute randomize before, and that was also generating sort of these random values. Where now we're doing it with a noise. So of course now we have more control over where it's going to be. Okay, so let's say we want to export these values to use for something else. So let's not put it into our color, but let's type bind. So bind will be for loading, and bind export will be for exporting. So let's bind export this as an attribute. Let's plug it into this thing, and by default it's called parm. We don't want it to be called parm, we want it to be called pscale. All right, so we called it pscale. And you can see we have a pscale attribute. So maybe instead of, because we're doing it now on this grid, maybe we don't want to scatter some points on it. So I just did that to sort of visualize it with the color easily. But again, like if we also put it on color, you can see this also still works. So you can see now it's doing it on the points, and now we have some like control on the points. So we have the attribute being added onto the points. So what we can now do is we can copy the points. Remember, turn on back an instance, because we want to instance. Let's put down a sphere. Let's plug it in. And you can already see we get kind of a cool thing going on here. So now, if we change our noise effect, so let's put this to, for example, to $T. You see we get our noise animating through our copies. And again, like this could be any object. We could make it a pig, make it a box. Let's do a box. Maybe box might be cool. So we're doing that. We could add a multiplication in here, for example, to, let's say, okay, maybe we want to have some control over how big, and you can label this, so call this scale maybe. So if I increase that, I have some control over the absolute size. So now I have my copies animating through with the noise. So maybe I could add another noise. So let's copy and paste this noise. Let's not promote these parameters. Oh, sorry. Let's not promote them. We want to maybe drive them based on the same noise that we have already, but we want this one to be a 3D noise. So what we can do is we can click on these parameters and then just plug those in the second noise. So this will be parameter, and I'm going to move stuff a little bit around. I'm going to stop my thing. So I can click on frequency, put this into frequency, click on offset, put this into offset, amplitude. As you can see, it's just like we can just use these same parameters in the other noise. Like that. Roughness. So now we have a 3D noise here. And of course, we can use this 3D noise. So this will be a vector. So remember what else is a vector. So color is a vector, but also normals are a vector. So let's put it into normals. Let's see what will happen. Because remember before with the talking about attributes, remember we were using the normal to sort of orient our copies. So now you can see they are sort of randomly changing based on the noise. So that's already looks a little bit more interesting. So we could do more stuff here. We could say we have the offset. Maybe we want to add something to the offset that we have already. All right, so let's do a little bit different. Let's let's see this offset here. Let's put offset in there and then put offset in there. And then take that thing and make this a float vector. Now we have more controls here, so it will still work like this, but maybe we could also, like, let's say, That looks a little bit weird, maybe. It's a little bit extreme. I'm not sure if I'm actually liking the way that looks. So that doesn't look that great, so I'm just going to remove this ad. But you can see the cool stuff that we can do with this sort of thing that we're doing here. You can, of course, like change it like that. Maybe we could do some other thing. We could say that let's bind export another parameter. So let's make it a vector. Let's call it scale. Remember, we can use, as you see, it sort of disappears because scale will be the non-uniform value. So like if I were to promote this parameter here, for some reason this is not doing anything. It's a bind, sorry. Needs to be a bind export, of course. Bind export, scale, tree floats vector. Let's promote it. Let's put it to 1, 1, and 1. Okay, when you also needed to put it by to defaults for some reason. Anyway, so now you can see we also have some control here over our Y scale. So we could also say that maybe right now we're setting this by ourselves. Let's not do that. Let's put this back to 1. So this will be our. So let's say we only want to change our Y scale. Okay, what we can do is this is a vector. Let's split this vector into each individual component. So remember, a vector is just 3 values, so x, y, z. So what we can do is type vector to float, and that will split the vector into an x, y, and z component. And then type float to vector, and then put these values back in, and then put it back into scale. So by default, this will not do anything. You can see nothing happens. We still have this control here. Exactly the same as was before. But now we can add stuff to our Y component individually. So let's first try it just with a constant. So let's promote this. Let's give it a, call it Y scale. Okay. This needs to. For some reason, this is messing up a little bit. Let me see what's going on. Okay, so there's something weird going on with our scale there. So for some reason, this was zeroed out again. Let's go back to our scene view. All right, so now we can see we still have these same controls here. So nothing changed there. But again, now we're doing it with this parameter. So instead of adding that ourselves, maybe let's add the noise. We already have a noise there. Let's add that one. Let's see what's going to happen. Not that much. Maybe multiply it. Maybe multiply constant. Let's do a 10, 50. So maybe a little bit extreme, 35. Right, so now we created something pretty interesting. And again, these are just copies, so we can copy our pig as well. So now it's a pig doing this. Now it's a sphere doing this. Let's keep it a box. So I know this is probably a little bit difficult to understand what's happening here, but what you're just doing is taking values and adding other values to it, multiplying other values. And it's just working on these attributes that we have in the spreadsheet. So it's just adding stuff to these attributes. And we're doing that based on the noise, based on the multiplication, based on an add function. And we can just write them out as an attribute with a bind. So I know this is hard to wrap your mind around. I had some trouble wrapping my mind around when I started out. But this is a very, very, very important part of Houdini. And this is something you really need to understand. This is one of the fundamental things that you need to understand. And we're going to use this a lot more all over the place in this course. And at the end of this course, you will understand how to use them, hopefully. And yeah, and then you can make super cool stuff. So I really want to challenge you to have a go at this yourself, maybe try out some stuff and see what you can come up with. Maybe apply these techniques to another piece of geometry and just try making something cool. I know this is a little bit tricky to understand, but we will be using VOPs a lot, and it will become clear the more you use it. So see you in the next video. Hopefully you found this cool and your mind is not breaking down yet. But yeah, so this is a very important part of Houdini, and you really need to understand what we're doing here. So see you in the next video, guys.